Hi, I'm Dominic Wee and I lead Google Cloud's Industry Solutions team for manufacturing and industrial. We are proud to support a broad range of manufacturing companies on their digital transformation journeys. Those companies range from small, highly specialized players to global conglomerates. At Google Cloud, we have built a team of experts that deeply understands the nuances of manufacturing companies. We are building industry-specific solutions leveraging Google's unique AI and infrastructure capabilities. Our customers work with these industry-specific solutions, as well as with a variety of capabilities that we have in Google and Alphabet. Those range from our suite of collaboration tools, G Suite, to cloud infrastructure and AI, to specialized hardware such as Google Glass and our dedicated edge machine learning accelerator Coral. In addition to these efforts, we partner with leading technology providers in the manufacturing space. Today, I would like to discuss Google Cloud's perspective on manufacturing, how the COVID-19 pandemic impacts the industry, both short and long term, and how we see technology helping the industry respond, recover, and reimagine. As an industry with a lot of history, this isn't the first time manufacturing has experienced disruptive changes. What previous adversities have shown is that while some effects may have been temporary, each of these global challenges has accelerated emerging trends and brought lasting changes to the industry. World War II massively accelerated the share of women in the workforce. In fact, between 1940 and 1945, the US female labor workforce grew by 50% to a height of 20 million. The 9/11 attacks demanded hardening of physical assets, including factories and refining operations. And the recent financial crisis accelerated the transition to low-cost countries for manufacturing. Which lasting changes should we expect coming out of the current disruption? The immediate change most of us are currently going through is increased health and safety requirements. Remote work has become a default for many jobs. Particularly in manufacturing, we're seeing a dramatic uptake of our virtual collaboration tools, including companies that are using these technologies for the first time at scale. Many customers tell us that their way of working will fundamentally change beyond the current situation. However, we believe the deeper, more profound changes are yet to come. While the past decades have been characterized by manufacturing moving more and more to lower cost locations, we believe we'll see a reversal of this trend. This will have a profound impact on the entire manufacturing ecosystem. Most of all, the shift to higher cost locations will lead to an acceleration of automation and digitalization. This will be needed to prevent overall manufacturing costs from increasing. Those geographic shifts will also lead to a fundamental restructuring of supply chains to enable more diversification and localization. In mastering those changes, one needs to consider the industry's current situation. Transforming a manufacturing company is more involved than simply changing a website. Many competitively differentiating assets are physical in nature. These physical assets bring along their own operational technology stacks. Often, we encounter a patchwork of legacy systems that are both critical to business continuity as well as very costly to maintain and modify. You can see the challenge manufacturers have to quickly adopt change. One company that has persisted through times of hardship ever since its founding in 1899 is our partner Renault. During this most recent crisis, Renault used its 3D printing and injection molding capabilities to produce more than 100,000 face shields for hospitals and retirement centers in communities near its global manufacturing facilities. Renault also partnered with startups, the French government, and the maker community to pivot from dream to medical certification for much needed parts and ventilators in just 6 weeks. I'm very excited to have Eric Marchiol, Renault's leader for Industry 4.0, with us today. Hey Eric, thanks so much for joining us today and taking the time to have this conversation with us.
Hi Dominic, thank you very well for giving me the opportunity to explain our strategy.
Renault is a very large and complex organization. What role does technology play in helping you scale?
So for sure we have operation in nearly all countries across the planet and many plants. And in all our plants we are extracting data from our equipment and bringing those data to life with standardization and real-time access is really a big challenge. and the quantity of data is quite huge. We have 500 million of events that we record each day in all our plants, and we need to use those data on a real-time basis to improve our operation for energy, for predictive maintenance, or for cycle time optimization.
How are you using data outside the four walls of the factory, for instance, in your supply chain?
The supply chain is very extensive in automotive and across the planet. So being able to track and trace all our parts from all our suppliers, not only tier 1 suppliers, but also tier 2, tier 3 suppliers, and bringing this information in real time, not like we've done by the past, I would say at the end of the week or at the end of the month with the inventory. Bringing the data in real time is now for us a game changer. So a decision that was taken by a plant managers or an industrial director is now taken directly by a technician or an engineer directly in the field before the problem is too big. And it is really important also in mindset change that the data gathering in real time is giving us.
What role does artificial intelligence and machine learning play?
Machine learning, we are using it for, I would say, 2 or 3 basic activities. The first one is for quality control with cameras. We were using from a long time ago, I would say, vision cameras, but it's costs quite a lot of money because we do it, I would say, in the traditional way of implementing those stations. And now with machine learning and a simple device, we are able to divide the cost by 10 for implementation of those quality control. And also what is very important is the time to implement those devices is also completely different. In one case, you have a traditional industrial project and you will need about 1 year to from the decision to the implementation. With machine learning and I would say on-the-shelf technology, we can target first implementation in less than 1 month and a generation in 2 or 3 months for multiple control area. Another topic about machine learning is about energy optimization in our paint shops. So how we can gather the data we have from our equipment, but also from outside, from what is humidity and all those information to process in a real time the best process parameters for energy savings in our paint shops. And we believe that we can have savings between 10 to 20% of energy consumptions in our plants with machine learning technologies.
Thank you, Eric. That has been incredibly insightful. Thanks so much for taking the time and joining us today.
Thanks a lot, Dominique.
It's inspiring to hear how an iconic manufacturer like Renault has continuously innovated for more than a century and will continue to do so. Now let's talk about how Google Cloud is working within the manufacturing industry. There are 3 main areas in which we engage with our customers. Firstly, maintaining business continuity. This is still on top of mind of many of our customers, and we expect that we will continue to see increased volatility in the external environment. Secondly, operations optimization. We are helping customers achieve the next level of efficiency using digital tools. Thirdly, openness and integration across OT and IT environments. We want to meet our customers where they are. We embrace the complexity of existing systems in manufacturing. And we embrace the desire of our customers to keep mission-critical data and systems on their own premises. I'll now dive into each pillar a bit more. Starting with business continuity, all manufacturers are facing increased challenges in maintaining health and safety in the workplace. We help customers achieve business continuity through our virtual collaboration tools. Wissmann, a German manufacturer of heating, industrial and refrigeration systems, was able to keep up its production with G Suite, helping them convert employees to remote work within a 48-hour span. Now they're conducting roughly 60,000 Google Meet conferences per month. The other aspect to consider for business continuity is the impact on planning. Often, planning involves taking the previous year's plans as a reference and making incremental adjustments. Clearly, given the current volatility, this approach breaks down in many cases. Using our state-of-the-art machine learning capabilities combined with our collaboration tools, we can help manufacturers transition to a more agile planning regime, relying more on external signals. Our approach leverages experiences we have made in areas such as retail manufacturing. We are helping California Design Den, a manufacturer of high-quality bedding products, better sense customer demand, harmonize the customer experience, and optimize forecasting accuracy. In doing so, they achieved an increase of 95% of forecast accuracy and reduced inventory carryovers by 50%. Secondly, turning to operations optimization. Continuous improvement is the lifeblood of manufacturing. For more than a century, manufacturing companies have driven innovations such as the introduction of the assembly line in 1913, mass production, and more recently lean. However, returns on investment for those innovations have been decreasing over time. The question is, what can be the next accelerator for optimization in manufacturing? We believe that artificial intelligence holds the potential to play this role. Artificial intelligence, or AI, has reached a level of maturity where it has become an essential ingredient in many of our consumer products. For instance, in how we improve search results. We are seeing many promising applications of these capabilities in manufacturing. And we believe that the increased push on automation and digitalization mentioned before will accelerate the application of AI at scale in manufacturing. A great example of AI use is AB InBev. AB InBev makes about 630 beer brands in 150 countries. They use our technology to reduce costs and improve quality by optimizing the beer filtration process with much greater accuracy. Another great area that illustrates this particularly well is quality control. Today, the manufacture of many products from cookies to windmills requires manual quality control processes or ones with very expensive automation. With visual inspection, we can offer a simple and cost-effective answer. We've applied this, for instance, at LG CNS, one of the world's most recognizable electronics brands. Our machine learning model reaches an accuracy of 99.9% for defect detection on display panels. The machine learning model runs on the edge in this case, since 200 images need to be inspected in 0.8 seconds for each and every display. What's special about our approach to visual inspection is that it's particularly easy to deploy and use. Setup is quick, and thanks to pre-trained models, the number of images required to train a new model is reduced. It's fully integrated with our AI stack, making it easy to scale across a multitude of adjacent use cases. Forrester notes in their recent report, The New Wave for Computer Vision Platforms, that Google Cloud is the platform to pick that can do the most for the most. From business users to developers and data scientists, Google has powerful computer vision tools that all of them can use. Lastly, coming to openness and integration across OT and IT environments. A common issue in making technology work in a manufacturing environment is the ability to scale up from an initial pilot. Underlying this challenge is the complexity of the existing IT landscape, particularly when a company runs dozens or even hundreds of manufacturing locations. With Anthos, we offer a solution based on Kubernetes to integrate IT across on-premise environments, edge devices, our own cloud, as well as other clouds. It's a software-only stack, enabling manufacturers to leverage existing investments in IT infrastructure. Moreover, with our serverless data warehouse BigQuery, we help customers harmonize their data across a myriad of sources. For instance, Kaeser, a leading manufacturer of compressed air and vacuum products, uses Anthos to combine business data with machine data and drive unique insights across the enterprise, as well as streamlining customer data in real time to optimize service. Additionally, with our support for OPC UA, a machine-to-machine communication protocol for industrial automation, we can utilize factory machine data in Google Cloud to facilitate advanced manufacturing insights as well as to control and monitor production processes. Our support for OPC UA is aligned with our commitment to open standards and interoperability between machines and systems to enable advanced analytics and AI. Renault, for instance, has adopted OPC UA as their company standard for machine-to-machine communication. Renault will both retrofit existing machines as well as purchase new OPC UA-capable machines to establish an industrial data management platform built on Google Cloud. This will also allow Renault to standardize a data model describing operations globally. To recap, we are helping manufacturing companies around the world, big and small, in three main ways: maintaining business continuity, optimizing operations, and facilitating openness and integration across OT and IT environments. Stay tuned and explore the next on-air schedule for deeper dives into the solutions we've outlined and much more. Many thanks for your attention.